How's it going? Today I have a video showing you guys what I did today, because yesterday was a different video that I did yesterday. Anyway, it is 6 o'clock right now, and in about an hour I'm going to the gym, so this is going to be like a good transition from me coding for the last 3 hours to the gym. Anyway, here's what I did. It is right now being glued, but as you can see, this new addition to the battery management thing. I can't find the actual like solenoid that pushes it. I just lost it somewhere, so I'm a bit confused on that. But otherwise, we have this. So as you can see, it's another CD player or CD changer, mover, whatever, on top, and it goes. As you guys can see, it's moving up. I can move it myself, I think. Okay, that is about the distance it'll be at the entire time. So right here, there's a clear plastic. On that plastic is going to be another clear plastic going down, and here is where the battery gets put in. Now, if you can already tell, the vision is, because there's a switch on here too, it'll be like, oh, it's not reading anything. So if we move this, and you guys can probably understand, there's going to be a clear plastic that with a metal tape, metal whatever, and it moves this to left, and then the clear plastic hits the battery. And on the other side is probably going to be like a magnet on a string. Like, I was thinking about making it like this, where I lost the magnet. That's great, that's great, that's great. Oh, here it is. Okay, well, another magnet, but whatever. There's going to be like a magnet here. There's just a magnet on this. But it's going to be like a magnet here. And then once it once it senses that there's a battery there, it hits the battery and it's like, oh, there's a contact. So that's how the battery is going to be tested. And once it's tested, it's going to be like, oh, there's a battery of there's a voltage of 3 exactly. Then it's like, all right, cool. Then it does the little shock thing, checks it again, 3.1, cool. And then it, oh, right, does that. Now, not exactly like the arm or like with the finger, but yeah. I might make it using this, like the top one, because the bottom solenoid is going to be crazy. Like, when I tested it, when I tested it, it flung it to about here. So we have this space. Now, I don't exactly know if this has enough travel to move the battery out of the way. So that's the kind of like thing that I'm going to be dealing with. But let's just assume that it does, right? Let's just assume I've cut this like little ridge because it gets stopped on that for whatever reason. That I cut this out and I push this. At which point does it tip over and we can go on to the next stage? That's actually a pretty good... I might implement that into this. So if the battery clears the check, the voltage check, this pushes like that, like a sweep, right? Like a single sweep. Because it's a lot simpler to make a single sweep than to be like, okay, stop here, check, go back. I just power it on, power it off. Easy. Instead of a single solenoid doing both of the work of the check and the dispose. Because if it gets it wrong, boom, good battery gets disposed. Boom, bad battery gets in. So yeah, that's the kind of thing where I'm at. The top motor is glued in already, so that does work. There's some little caveats I need to fix, but otherwise it works. Anyway, now to the actual coding section, which some people find interesting. I don't, but I have to code, so here's the code. So let's begin. Let me hold on. Let me fix this screen. Okay, so let me make this a. Okay, I was just listening to some music. Okay, so we have this. We have the code. As I said, no AI, no vibe coding, all me, all the brain here. Okay, so this is the operating sequence. I think I already gave all of this in previous episodes, videos, whatever you want to call them. So yeah, we have the includes. We have I'm making this a lot nicer, making this look a lot nicer, and also this is the third implementation of this code, so many things have changed, and this is not like working code right now. If I try to upload this will not work because I changed so many things. Like this code is old stuff. This is old, and also almost 200 lines of code. Anyway, I'm just gonna go through up until the void setup because most of this is finished. Okay, so we have constant int pin, the LED pin for, okay. Okay, so this uses the LED pin for viewing, and it's like, oh, once the thing is done, it blinks and shows that it's done. We have the SD card pin, which just reads the SD card and writes to it. I don't know how an SD card would work, so I'm just putting it into one pin. We have the same motor drop pin for this motor right here. This one that rotates this way. That will... It's basically like an onboard H-bridge. So I'm going to set this as an input and output, and set this as a, well, high and low, I should say. And this is a high and low. Then we have the conveyor switch, which is... see if I can show it without breaking all of my hard work. This guy right here, this is the switch. So when this cassette is all the way down, it's just gonna read it as open, and when this moves up and contacts the switch, it's gonna read it as closed, and then it can move on to the next stage. Okay, let me put this how it was before. There we go. So we have that. We have the conveyor motor pin, which you can probably guess it's this motor right here. Again, H-bridge, and it's placeholder pins because I need to look at the thing. I was just going from just random numbers essentially. Then I have the booster relay, which will boost the 12 volts. Oh yeah, powering the 12 volt to the battery. And again, a placeholder pin. Anything with the bracket or the parentheses is a placeholder. Then I have the probe relay or probe drop relay, which is the solenoid. It's like, oh, bad voltage. Boom! And then it deletes the battery. And then I have just a relay because I have 3 relays. So where are they? Yeah, there they are. I just have 3 relays here. I found one, so we have 3 to use. I only need 2 technically, but I have 3 to use. Okay, and now we have the floats. One of them is the minimum voltage for, well, once again, the probe. So when it like does that, it reads it and it's like, oh, 2.7. 12 volt power. 2.7. Boom. Gone. And if it's like 3, it's like 2.7. 12 volt power. 3.1. And then it goes forward. So yeah, sort of like that. Then we have the voltage from the charging, like the end voltage that it should be at, and then the end voltage from the discharging. So this is like the difference for power measurement or for capacity measurement. There we go. Oh yeah, so I changed the enums from like what they are to just stages, because for me it's simpler. And I also put a lot of comments. I really like comments. So it's like stage 1 is preloading and the loading stages for the batteries up until the conveyor. So basically, it's very simple for me to explain it from the comments and to here. So basically, batteries get loaded in. Boom, boom. Up until this motor, this is stage 1. So like, everything is idle. As you can see, loading is idle. Load feed battery is idle. And then load complete. It's very simple. Because this is idle. Then it's waiting for the battery to feed in. There is no sensor, so I'm just going to use the sensor of the switch down here because it's just going to be constantly in one place. I have to keep this horizontally, so I'm not going to be able to show you guys everything because it's still drying. Like, literally, that's new. Anyway, stage 2. All right, let me do this. Stage 2, the conveyor and the transport and feeding. This is for the unsigned long. Yeah, stage 2. So we have the switch check, which is the same switch I showed you guys, which is this one. Then we have the conveyor belt idle, or conveyor idle, conveyor feed, and conveyor complete. So conveyor idle, it should be this, should be down here. That's how it checks if it's idle, if the switch is closed. Then conveyor feed, beep, stops here. And then once it does all of the things, like with the conveyor this way, or the battery conveyor this way, then, well, the probe, I guess, this way, and then it does all the things. Once the battery is either accepted or denied, this goes back here. That's conveyor complete. Stage 3. This checks the voltage and does the actual probe. So this and this is a separate stage. So this is stage 1, this is stage 2, this is stage 3, and I'm going to have a solenoid on the side here. So this basically does a switch voltage check, which is actually this switch right here. It's not pressed, but if we do... Oh, wrong way. As you can see, now that is pressed in. That would say, okay, voltage or switch voltage check is good. We can move on. Then it goes into probe idle. Or it stays at probe idle and then it does the voltage switch check. I still haven't figured that out yet because it's kind of here and there. It's kind of both at the same time. So I'm still trying to figure which one should be first and which one should be second. Anyway, though, we have the probe sensing, which is basically just move in, read the voltage. And then if it gets declined, you know, boom, that's the probe actuator. So probe sensing, probe actuator. I'm not done yet, so this is still a proof of concept. Stage 4, charging the battery. I didn't finish. Yeah, this is not done yet. Stage 4 is charging the battery. Basically, once it is here, goes down, checks if there's a... Well, first, it checks if there's a battery. If there is, great. If not, there should be one. So it's in this here. So it's probably going to be like a Boolean of sorts. It's like, oh, true or false, whatever. Anyway, and yeah, I didn't finish this. This is from here. This is from old code. So yeah, this is from old code. But yeah, I have 5 stages and then a self-check. This self-check should be run once before the motor, before, like, on startup, basically. So like just avoid setup. It'll check the, it'll check the switch pin, the probe switch pin, the VBAT, the voltage battery pin, the charger, the capacity, and the actual battery ID. So if on startup there is a battery ID of sorts, it deletes it. So it's like goes to UUID 0, so battery 0, starts the thing. But before it does, it checks the switch pin, this switch. It checks the probe switch pin, this switch. It checks the V battery, voltage battery, pin, which is probably at the charger, not going to be here because if the probe is out, it's not going to be able to, so probably at the charger. And then the capacity check, so if there's any capacity saved, I guess, then it deletes it. So basically just a brand new wipe of the system. And let's see what this says, I forgot. This is the staging procedure for the microcontroller goes through on boot up. Yeah, that's what I said, to see if everything is set up properly for operation. Yeah, basically exactly what I said. Can you tell I didn't sleep well? Yeah. Anyway, we have stage 1. Oh yeah, I didn't finish this either. We have stage 1 through stage 5 that I'm going to do for timing. Well, some of them don't even need timing. Oh, some actually, I think all of them do. Anyway, we have this. I'm mainly, you know, pretty proud of this one. It makes a structure of battery ID. Can I zoom in? Okay, that's good enough. Makes a structure of battery ID. I'm just gonna read you guys the comments. Actually, I'll just explain what this is in better detail, I guess. uint ID is giving a number to a battery, to every single battery, and then in the code is going to be plus plus. So it's just going to give a battery an extra. For every additional battery it does, it just gives another number. So it's like 1, 2, 3, 4, 5, and it goes on. And every single time it resets. Maybe. I might not make it reset because, yes, I put it in the code to make it check and reset it. But if we have like 100 batteries and 5 resets, how are we going to know if it's 20, 20, 20, 20, 20, or is it going to be like 17, 13, 30, and whatever? So I might. But this is what gives the battery a number. Then it reads a voltage and current at a given time. So basically it's like, it saves that as a number. Can I? There we go. Yeah, it saves it as a number of, what is that, 4 bytes? What is that, 1024 or something? Yeah, whatever. So it saves this as voltage. I should probably say volts, this as milliamps. Okay. Okay, cool. And then this is going to be the initial starting and final, or yeah, the initial voltage and final voltage of the system throughout the charging stages. I just read this basically, but this is when it comes in. It records the voltage. Yeah, it records the voltage. So when it's like, as soon as it gets accepted, goes down to the charger, reads the voltage, it's this voltage. That is the voltage. And then it discharges, and then, well, discharges, or it charges up, and then it discharges for capacity testing, then charges back up for the final. That final is this. Final voltage. Then we have a float for capacity of milliamp hours, but as I said, maybe just milliamps. So it stores the capacity in numbers, obviously, throughout the test. So it's not just like 1 milliamp hour reading. It's, well, I might just make it milliamps. I don't know. I don't know yet. I might make it watt hours actually, because that's actually easier to understand, because it's both volts and amps multiplied together with time. So I have no idea. I'll have to see. And then, oh yeah, we have this makes the ESP32 record the time when it comes in to the charger. So it comes in, it records the time, it records a voltage, and it records the battery. Oh yeah, it does 3 things. So then it does, I don't know why my head is like, it's pretty dampened here, so hold on. There we go. So yeah, it records the time, and then it does the charge start time, yeah. So once all the things are done, once the battery is identified or given an identity, then once the arrival time is recorded and the initial voltage is recorded, then it's given the charge start time, which is probably like 5 seconds later. But still, I mean, maybe there's an error of sorts along the way, and then it does the discharge start time. Oh yeah, then it does the 3 booleans. So, is there a battery there connected? If there's no battery, we have a problem. So this is a true or false. Hold on. I just learned what a boolean is today, so... Well, relearned it. Okay. So, we have a true or false, whether there's a boolean, whether it's charging, and whether it's finished charging. Finished charging. Are there any, like, errors along the way that I made? Probably many, but whatever. Okay, so, yeah. This is whether... Oh, yeah. This is the most important part. I had to specify this. This is the most important part of the check, because it checks if the battery is there and connected by checking if there's a voltage. So it's basically doing if there's a battery there, but the connected and by reading a voltage is just because if there's a battery there. So whatever. Anyway, if it's false, it's waiting with some other stage. It's waiting in like stage 1 or something. Then it does charging. So is the battery going through a current of sorts by reading a current? So it's like, oh, there's a current. And oh yeah, and how it's reading a current, I decided on using a shunt because I don't have a sensor or whatever it's called, like a Arduino sensor for reading current, so I just decided on using a shunt. I'm probably gonna like regret that later on because it's a lot of formulas for like using very low resistance and monitoring all of that. So I'm gonna have to probably use 32-bit integers like in the decimal places for reading the voltages, but whatever. Anyway. Oh yeah, and this is the second most important, but it's not really. So once everything is finished, it needs to record everything into a file, into like an SD card file. And I did calculate it. It's about like 250 kilobytes of storage from one battery from like an hour and 15, hour and 30 minute test. So it should take like hundreds of batteries if I'm using like an 8 or 16 gigabyte SD card. Oh yeah, and then this is just, at this point it's gibberish because I've changed almost everything. But the same code still works because I didn't like upload this yet. I will actually save this as day 4 now. Day 4. Okay. Cool. We can still... Let me show you guys what I did actually from yesterday. Because it's still recording from the old code that I did. So, we have the microcontroller. Let me do this. We have the microcontroller. The system is sleeping and is waiting for the next battery. If I touch this now, it will say battery is ready. It will read the current from the analog pin. It says motor has dropped the battery, and then battery ready. And then until I stop touching this, it is on a delay. I think it's like 5 seconds, unfortunately. So yeah, it says counting down now. So no battery, counting down. And then if I touch this again, it'll say battery seen, battery ready, record the analog current, and say motor has dropped a battery. So that's what I changed. That's what I changed from last time. Not much, since it'll be useless in like 30 seconds when I try to upload this code, and it's like, oh no, it ran into 30,000 issues because it doesn't see anything from yesterday. So yeah, I have no idea where my solenoid went. I'm legit, like I was sitting here listening to music and I was just trying to find it for quite a bit actually. It's gonna be like the dumbest place. I'm telling you right now. It's gonna be like, oh, it was under your chair this entire time. No way. It was actually under the chair. So, this is the solenoid, and it basically extends and retracts. Very simple. I'm not kidding. I literally just found this after an hour of searching. Well, not an hour, but like I think an honest 15 minutes. Okay, let me then show you what it's supposed to happen. I don't like holding this how it's supposed to be because the glue is still not dry. I'll do this for you guys. Anyway. So, let's put this down here. Put this right here. Let's angle this like this. And let's go through the paces. Hold on. I'll give you guys this red battery. So, assuming everything worked well, right? It went through the funnel, it did all that, and now it's in here. And now, boom. So then, the top piece right here, the plastic piece, is going to push this here a little bit to record the negative side, and then a magnet is going to be attached to here and record a positive side through like a wire or something. And then, let's say a battery is bad, and hold on. Let me connect the wires to this. And let's say a battery is bad, and it needs to be pushed this way, like fully cleared, because we need space for the next battery. So let me show you guys. My apologies for making this a long video, but I really don't want to edit. Let's see if this is the correct... It is. Okay, cool. Wow. Yeah. So, this is sprung down, and I'm probably going to have to connect this to a relay and then backwards, because it needs to be... So, it extends one way, and then it retracts another way. So, it needs to be reversed, like polarity reversed. Anyway, here's what it looks like, connected. Oh, oops. That was a little bit anticlimactic. Let me do this again. There we go. Cleared. Absolutely cleared. Yeah, so it was actually a little bit better. It was a little better before. I don't know why it's not good now. Alright, anyway. Let's try this again. Let's try this one more time. Here, I can't really see. Let's just hope it's there. There we go. That's what I was talking about. So yeah, look. Battery is here. We have an entire battery worth of length here. And then we have the actual contraption. So that's the ideal. And I'm probably going to have to, like, glue and sand some stuff down, but whatever. That's fine. That's fine with me. I would rather that than nothing work. So, we got that working. Great. I just need to glue this down and, like... See, like, with this would be, like, the perfect use of an H-bridge, because then I can easily extend, retract with 1 voltage and, like, a single sense pin or whatever. Oops. I almost broke this guy. Cannot have that happen. Anyway, yeah, so that's good. I gotta glue that down. I gotta make something out of that. And fix the code, because right now, if I... Let me try to upload it. Let me try to upload it. I'm gonna be like, oh, No can do. No can do. Also, I reduced the capacity voltage from 3.7 to 3.2 because a single volt of drop means like 98% of the whole capacity. But if it was 3 point or 4.2 to 3.7, it would be like, how many errors did we get? Wow. Oh, that's a lot. Oh, not declared in scope. Yeah, because I deleted most of it. So yeah, whatever. Yeah. What was I trying to say? I don't know. Whatever it was useless. So, oh yeah, the 3 point, because most of the capacity is actually from 4.2 to 3.2, not 4.2 to 3.7, and then try to interpret that. So, whatever. Its nominal is 3.7, charged is 4.2, discharged is 3.2. So yeah, that's what I was trying to say. Yeah. So yeah, all right, whatever. All right, guys. Well, hope you have a good day, night, morning, afternoon. Have a good one. Peace.